Hi. So previously we have discussed the a new solution concept in the extensive form game with imperfect information, but with perfect recall. So that was the sequential equilibrium, right? So it asks for two things. So first, we need the consistency for the assessment, and we also need the sequential rationality, right? So in this video, we'll use example called Selten's horse, and which game tree looks like a horse, and that is named after the author Selten. Okay, so let's use this example to try to find the sequential equilibrium by constructing, by satisfying all those requirements. Okay, good. So here we already have this game tree, and I have already labeled all those behavioral strategies. So, so this game first, player one moves with two different actions, capital C or D. Then if C is played, then player two gets moved to play little c or little d. If C and C are played, then game ends with 1-1-1. If little d is played, or if player one play capital D, then player three gets to move, right? So here we have an information set for player three to connect those two histories. And here, player three could play either L or R, but cannot observe this information set, right? Okay, so here we have labeled this all those behavior strategies for such as for player one, we have 1 minus p epsilon, and for D, and p epsilon for C, and for player two, q epsilon for little c, and 1 minus q epsilon for little d. And similarly for player three, we have alpha and 1 minus alpha epsilon. This is not alpha to the power alpha, right? This is funny. Here this should be 1 minus alpha epsilon. Okay, so those epsilons are not the powers of those p's or those probabilities. Those are just some functions. Okay, so something to this epsilon would be just a function of epsilon. Okay, so later we'll define or we'll construct those functions to satisfy the consistency requirement. Okay, so for now we will just use those letters to denote the different probabilities. Okay, so so here we have those notations. Okay, beta 1, beta 2, beta 3. So we already know what they stand for. So this mu epsilon in this information set, D or CD. So in this information set, so let's say that this mu is defined for this probability of, for this belief of played, for player one played this capital D, okay, which is here, which is this, right? So we simply define that as this probability, okay, and that could be derived from the base rule, right? So base rule simply tells us how to update the belief from the prior to the posterior, right? So here, after updating the belief, then this numerator would be 1 minus p epsilon. So that would be the probability of reaching this specific this node, right? But the denominator would be the summation of all the probability coming into this information set, right? Okay, good. So here we have all those probabilities in an open set of between 0 and 1. So it means that those are totally mixed behavioral strategies. Okay, good. So and that would be helpful for us to construct the sequential equilibrium, right? Since we need those to make the base rule work, right? Good. So and those different probabilities in limit, they'll converge to those notations, right, without the limits. Okay, good. So let's analyze this game and solve this backwards. So player three is the last player to move, and now we write down the expected payoffs for player three. So first, let's say if player three plays L, okay, he plays L, then we have those possible outcomes, right? So this would be simply 2 times the mu, right? Mu is the probability for this for this for this capital D, right? And 2 mu, if play R, then we have 1 minus mu. And in limits, we could write down the belief in terms of the base rule that we derived, right? Good. So those will be useful later for us to calculate the specific numbers for those things. Okay. All right. So and how to analyze that? So let's say let's compare those two things, right? Let's say if 2 mu is bigger than 1 minus mu, then mu has to be greater than 1/3. And in this case, it means that okay, if this is better, right? So if that is better than player 3 plays L, if player 3 plays L, then it means that it simply means that alpha equals to 1, right? So alpha would be simply the behavior of the player 3 strategy, right? Okay, and similarly, if 2 mu is less than 1 minus mu, then mu is less than 1/3, and player 3 plays R, and alpha essentially equals 0, okay? And if that equals 2 mu equals 1 minus mu, then mu is exactly 1/3, and this alpha, this behavior strategy could be anything from 0 to 1, okay? Good, so then we could move up and solve it for player 2. So we write down the expected payoffs. Let's see if we have the correct results for this. So if player 2 plays C, little c, let's see what is it. So player 2 could get this 1, either this 1 or get the expected utility from this 4 and 0 with the probabilities, right? Okay, and that would be 1 here, but if player 2 plays D, right, if C is 1 for sure, right? If D, that would be conditional on this alpha, right? Okay, so it will be 4 alpha, and we similarly compare all those numbers. So if 1 is bigger than 4 alpha, then alpha less than a quarter, then it means that player 2 plays C for sure. So in this case, it means that Q is 1. Or in the second case, if 1 is less than 4 alpha, then plays D and Q is 0. If they equal, then alpha is a quarter exactly, and Q is anything between 0 and 1. Okay, so that would be the analysis for player 2, and then we move again upward and goes finally to player 1. So for player 1's expected payoff, let's see if player 1 could play C. If that's the case, then what the player 1 could get in this case would be if 1 plays C, then player 2 plays C, then player 1 gets 1. If 1 plays C, then player 2 plays D, then player 1 could either get 4 or 0, depending on player 3's action, right? Okay, and this would be the Q plus 4 times 1 minus Q alpha, okay? And similarly, if player 1 plays D, then here what the player 1 could get is either 2 or 0 with the probability from player 3 strategy. Okay, so that'll be 3 alpha. Good. So and similarly, we could compare all those two numbers. And if the former one is bigger, then player 1 plays C. Then it means that P equals to 1. If that's less than the second, then plays D and P 0. In this case, if they're equal, then player 1 plays anything for this P that is between 0 and 1. Okay, so then we have all those behavioral strategies and all those different cases. Now we could combine all those cases and to start to analyze, to check the sequential rationality, right? So again, we start from the analysis from player 3. So we have seen that if 2 mu is bigger or equal to less than 1 minus mu, then we have this 2 times 1 is P, which is bigger or equal or less than P times 1 minus Q. And this is simply from earlier from here, right? So we have all those, and we simply compare the numerator of those numbers, right? And we don't because they have the same denominator. Okay, so here they have this relationship, and if we have this, then that, and further, if we have bigger than or equal or less than, if we have those relationships, then alpha could be either 1 or 0, or alpha is in 0 1 0 and 1. Okay, so those they have all those simultaneously, right? So we need to discuss which case would be feasible, or which case satisfy all those requirements for the sequential rationality. Okay, so let's check that by starting with the first case. If let's say if alpha is 1 here, okay, let's say if alpha is 1, okay, that is from the perspective of player 3, right? So now we move upwards, and then we go to player 2, okay, and then we could find that if alpha is 1, and then we find that 1 is bigger than 1 is greater than 4 alpha, okay, and that gives q is 0, right? So let's see, where does this come from? Okay, that comes from here, right? So if let's say if alpha is 1, okay, and that should be this case, right? So if alpha is 1, then of course that is greater than a quarter, okay, and that shouldn't be, okay, so this simply gives us q0, right? So let's check that. If alpha is 1, and then we check player 2's expected payoff, then here, since alpha is greater than a quarter, right, and then in this case player 2 plays D, and q is 0 for sure, okay, good. Then we plug q is 0 into this relationship that we just obtained, into this inequality, okay, from this assumption, because we said that if alpha is 1, then this has to be 2, right, from here. Okay, so we plug in that, and then we find that 2 times 1 is p is greater than p, then p has to be less than 2/3, okay? And also we have q0 and alpha is 1, and then we plug all those into the conditions for player 1, right? So we have finished those for player 2, then plug in to player 1 and to verify if there's anything wrong. And it turns out that if we plug all those in for player 1's expected payoff, then those are just the, recall that those are just the expected payoff on the two sides for player 1, right? And if we plug all those into the left side, and we get 4, and the right hand side gives 3, and that'll be a greater sign. So the greater sign corresponds to this case where p is 1, right? Okay, but here we could notice that p equals 1 has a contradiction with the condition earlier, that p is less than 2/3, right? So this leads to a contradiction. So it means that in this case, alpha is 1, that is not sequential rational. Okay, good. So now let's move on, and to check that for player 3, if alpha is 0, okay? So we check different values for this alpha. So if alpha is 0, then we have this inequality in the other way around, right? So, and then we plug into this the player 2's utility function, and to utility expected payoff, then we have q is 1. Okay, so if q is 1, then we plug into this inequality, and we find that p is greater than 1. Okay, and then we use those results to put into the player 1 6 utility, and the left hand side gives us a 1, and right hand side gives us 0. And this greater sign means that we need to find this greater sign, which is p is 1 again. Okay, so if p is 1, that has to that will be again contradictory to the condition earlier that we obtained, p is greater than 1, right? So those are the contradictions. So it means that here this case failed, right? So this is not sequentially rational. Okay, good. So now let's move on, and for player 3, let's check if alpha is between 0 and 1. Okay, good. So if alpha is between 0 and 1, and in this case, we also have that mu is 1/3, okay, and we also have this equality, okay. Good, so let's keep this in mind. And then we use those to check player 2, expected payoff. And so the first case would be that if here we need to be more specific, right? So because we have two variables in the same equation. So let's say that if q is 1, okay, if q is 1, then here we could solve this from this above inequality. So it simply gives us that p is 1 in this case, okay. Good. So if p is 1, and here we also have alpha is less than a quarter, right, given by this p is 1. Okay, and then we verify player 1, and the left hand side gives 1, the right hand side 3 alpha gives us something which is less than or equal to 3/4, and this is a greater sign, and that gives us p is 1. And we could see that p is 1 is exactly the same as p is 1 from before, so there's no contradiction here, okay. And this condition, so this one satisfies the sequential rationality, okay. Good. So that would be something for q is 1. How about what if q is 0? If q is 0, then we plug in this into the equation, and here we have this p is 2/3, and also alpha is greater than a quarter. So for player 1, we could verify that the left hand side gives us 4 alpha, and the right hand side gives 3 alpha, since alpha is a positive number. So here we have this greater sign again, so it means that p has to be 1. So again, those two yield a contradiction, okay. So this doesn't work, it's not sequentially rational. Okay, so the last case that we could check is what if alpha is exactly a quarter, right? So that would be the last case. So if alpha is exactly a quarter, then this q could be anything between 0 and 1. And then we go to player 1 and check that. So the left hand side gives us 1, and the right hand side 3 alpha is 3/4. So it is greater sign, and again p is 1. Okay, so p is 1 is of course is definitely okay, right? Because we are coming from here, right, all the way up to here. Good. And in this case, q is also 1. Okay. So here we could essentially combine those two cases, right? So here we could combine such that q is 1, p is 1, and alpha is less than or equal to a quarter, and mu is 1/3. Okay, good. So now we have completed the check for the sequential rationality, and the next would be something to verify for the consistency, right? Okay, so to do that, we simply construct some proper limit functions, as we just mentioned in the beginning, right? So let's simply suppose that this is not power again. So this is some function regarding notation for limit function regarding the epsilon. Okay, so it's simply noted by this p. Okay, so this function we simply define this as 1 minus epsilon. So if epsilon goes to 0, and this goes to 1, of course, And similarly, let's define q epsilon to this function to be 1 minus 2 epsilon, and that goes to 1, of course. Okay, so why we're having 2 epsilon here, and that'll be simply helpful for us to derive the correct belief in the base rule. Okay, so and we also have this alpha. Okay, so for any alpha which is not bigger than a quarter, then we say that we define the alpha epsilon to be alpha minus epsilon, and that given the alpha epsilon goes to 0, and then this converges to alpha. Okay, good. So all those are good, and then finally we have this belief mu epsilon, and that'll be the limit of when epsilon goes to 0, and this thing after we plug in all those functions, and that finally gives us 1/3. Okay, and this 2 epsilon will be helpful for us to finally find a good result for this that is consistent with the whole assessment, right? Okay, good. So and now that completes the whole verification for this sequential, not only the sequential rationality, but here also the consistency. So both together they complete the definition or those requirements for the sequential equilibrium, right? Okay, good. So this would be a quite long approach to construct and verify this sequential equilibrium, right? So later we'll also see some other similar but more brief solution concept in this kind of game. Okay, good.